All right, friends, welcome back. We're going to take a look at Lesson 8, Implicit Differentiation. In order to participate in this lesson, you would want to be sure of the product rule, the power rule, the chain rule, and also the quotient rule. So know that, and so if you don't know those things, check out earlier videos. But for now, let's take a look at implicit differentiation. Okay, so here's what we're going to try to do today. We need implicit differentiation for this problem. So the only other way to find the derivative here would be to somehow isolate for y and then find that derivative. And for the sake of time, we are going to learn implicit differentiation. It's a much better technique. Okay, so these are the couple questions that I'd like for you to be able to do by the end of our time together here. And let's jump in. So first off, let's just review what dy dx means. What it means is how is y changing compared to x? So as x changes, how does y change? So for example, if we looked at this example here, y equals 3x plus 7, what does dy dx mean? Well, it's really asking how is 3x changing as x changes and how is 7 changing as x changes? Let's make that visual. So if we were to look at 3x on its own, we would have a line with a slope of 3. So over 1, up 3, over 1, up 3, over 1, up 3. As x changes by 1, y changes by 3. The derivative is 3. Now let's look at the change in 7 over the change in x. Y equals 7 is a horizontal line at 7. So we can see we have these coordinates 0, 7, 1, 7, 2, 7, and so on. As x changes by 1, how is y changing? It's not. The derivative is 0. That's why we say the derivative of y equals 7x plus 3x plus 7, why we say the derivative is 3. Okay, so now what we're going to do is talk about implicit differentiation. So you all know that the derivative of this one here is 3. We just shared that, okay? Now what I want you to consider is let's look at this one right here. Notice that y is not isolated. Would you still be able to find the derivative? Well, you can. What's the derivative of y? It's dy dx. What's the derivative of negative 7? It's 0. What's the derivative of negative 3x? It's negative 3. Isn't that right? And so where did I put my solution there? You'll notice here that I wish I would have, you know what, I can't stand how I wrote that. This would be y prime minus 0, because the slope of negative 7 is 0, and the slope of negative 3x is 3. Equals 0. So can you see that this is going to be y prime equals 3? Look at this. Same stuff. I'm not a big fan of the dy dx notation. I like this much better. However, for implicit differentiation, it's really important to know that when we're taking the derivative, we can take the derivative with respect to x. We're comparing how things are changing compared to x on the Cartesian plane, which is what we just looked at back here. As x changes by 1, y changes by 3. That's why it's dy dx. How is y changing as x changes? Now what I want to do is just put an idea in here. Okay, so could you understand how if we asked you what the derivative of this is, you guys know the chain rule. So you know that that would be 5x to the power of 4. And you could also see this as you know, what if we saw this as the chain rule? What if we said there's an internal function here and it's x? We'd then say, what's the derivative of x? And we'd say, how is x changing as x changes? This is in a one-to-one relationship. So we'd say y equals 5x to the power of 4 times 1. We wouldn't even bother writing it down. And we didn't bother mentioning it when we were first learning this because, of course, there's no need to mention that, I don't think. So anyhow, that's the derivative. Now what we're going to do is we're going to get into some more, open up another idea, okay? So what I'm going to do is ask you, what's the derivative of x equals y squared? And in addition to that, this is not part of the question, but I'm going to create one x value to help you see what we have here. So if y was 3, then x would be 9. And I know that because 3 squared equals 9. So just hold on to that for a second. I'm basically going to ask, what's the slope at the coordinate 9, 3? I'm also going to draw what x equals y squared looks like. That's a parabola on its side. or it's a radical function with a top and bottom, okay? So here's the coordinate right here at 3, 9. So what I'm going to do is try to figure out what's the slope exactly there. There's a number of ways we could do it. One is we could isolate for y. So y equals plus or minus square root of x. Now I'm going to use exponential form, and now I'm going to use the power rule. So the change in y over change in x, or y prime, equals 1/2 x to the negative 1/2. Another way of leaving that is plus or minus 1/2 over 1 over square root of x, which simplifies to this. If we then said, what's the slope at the coordinate, oops, I wrote that down wrong, 9, 3, I'd simply take the 9 and I'd put it in here. I put the 9 right there. So we'd have 1 over 2 square root 9, which is 1 over 6. So the slope would be plus or minus. Okay? Now, that is true. The slope is plus or minus 1/6. So the slope right there would be 1/6, and that would be negative 1/6 there if we were looking at 9, negative 3 for what it's worth. Okay, now what I want to do is show you implicit differentiation. It's a bit quicker. Watch this. How is x changing as x changes? We'd say dx, how is x changing as x changes? And we'd all say that equals 1, and it does. The derivative of x is 1. This is the part that you're going to have trouble conceptualizing. How is this guy changing? How is y squared changing as x changes? Well, we know by the power rule that it's going to be 2y to the power of 1. Okay? But remember, this y is an internal function, right? Y has a value. I know what y equals. Y equals that. So if that root x was inside here, when I took the 2 down, I'd still have to multiply this by whatever the derivative of the internal function is. So now I ask you, what's the derivative of y? The derivative of y is dy dx, and I like to write that as y prime. So it's going to be 1 equals 2y to the power of 1 multiplied by y prime. When I rearrange that, I'm going to have y prime equals 1 over 2 times y. That's the derivative. That's what y prime equals. Now I'm going to ask this question. At the coordinate 9, 3, what would the derivative be? What would I put in for y? Would I put in the x value or the y value? Of course, we're going to take that 3. We're going to shove it in right there. We're going to have 1 over 2 times 3. That's 1/6. Can you tell, can you see that the derivative is the same for both? So I'd ask you, what would you prefer? Implicit differentiation or isolating for y? You may have noticed the plus or minus there. It's not that there doesn't need to be a plus or minus there. The reason we'd have a plus or minus is if we put negative 3 in here, the result would still be 9. So if I put negative 3 in here, I'd get the negative 1/6. So hopefully that helps you out. Okay, so let's go to the next problem. All right. Let's look at this guy right here. So what's the derivative of that? Well, I'm going to just talk you through it. So the derivative of this is, I don't like this notation, so I'm going to write this as y prime equals 5y to the power 4 multiplied by y prime plus the derivative of 2x is 2, and the derivative of 7 is 0. I'm going to clear that. And so there we go. So there we go. We're right there. Now what we want to do is isolate for y prime. Lots of you at this step will be a bit unsure. So let's go back to grade 9 just for a second. M equals 5m plus 2. And now what I'm going to get you to do is, let's say we said solve for m. What would you do? I think most of you would say, well, we're going to take all the m's to one side. So let's remember what we're doing. We're asked to find y prime. So what I want to do is get all the y primes to one side. So that's exactly what I did there. Now let's look at this line here. We want to get y prime by itself. Now you need to get creative. You need to think, what are all the things I could do at this point in time? Okay, this is not a matter of step 1, step 2, step 3. This is a matter of thinking. I want to get y prime on its own. So you need to go through your Rolodex of all the things you're allowed to do that might be helpful. At a certain point, you might notice that y prime is in both terms. What do you think we could do? Don't try to be perfect. Try something we're allowed to do. I bet eventually you're going to say, hey, why don't we just factor out a y prime, leaving behind a 1 minus 5y to the 4, and then we're going to divide that out, and there is our derivative, and we are done. That's a tricky question. Okay, Now let's look at this next one. This one says determine the derivative of x squared plus y squared equals 25 and the equation of the tangent at 3 comma negative 4. Perfect. So we're going to take the derivative here. It's going to be 2x plus 2y to the power 1 y prime. Hopefully, I don't like this notation. Anyway, I like writing it as 2y plus 2y y prime equals 0. And then as I isolate, I'm going to have y prime equaling, I'll have y prime equaling to negative 2x over y, 2y equals negative x. So that's the derivative right there, okay? And we were asked to find the slope at 3 comma negative 4. So the coordinate that we were looking for is at 3 comma negative 4. So all I need to do is put the 3 in there and the negative 4 in right there, and I can see that the slope is going to be 3/4. Okay, so now when I come to Desmos and look at Desmos, I'm going to create a little equation here. So let's go, I think the coordinate was, or the slope was 3x plus b. And now I'm going to find this and let's, oh my gosh, what a surprise. Look at that. Let's see if I can get it. Oops. Oh, that sure looks like the slope is 3/4 there. And it is. And I know that you guys know how to find the b value there. And so I'll probably leave it with you to do. But we know that the equation of that slope, and by the way, what you'd probably want to do is draw that circle, you know, plot it, plot that point. We're looking for the equation of the line. We already know that y equals 3/4 x plus b. What we don't know is the y-intercept. So what we're going to do is we're going to take the 3 and put it in for x. We're going to take the negative 4 and we're going to put it in for y and isolate for b. Okay, and so we've done that numerous times. Okay, just remembering that this coordinate here has to be the same on the circle as it is on the line. And the line goes through this coordinate. And so that must mean that the b value can be found from that, from plugging those coordinates in. A lot of people will miss this. This is the derivative. We are done. What follows is, how do we know that that's how do we know that's the derivative? Well, another thing we could have done here is we could have isolated, excuse me, y squared equals that, take the square root of both sides. Now y equals plus or minus square root of 25 minus x squared, which is true. Notice this piece right here. That's what y equals. Okay, so we could literally sub it in there. And if we then went ahead and plugged in, x equals 3 in here, notice what you're going to get. You're going to have 25 minus 3 squared, which is 9. 25 minus 9 is 16. The square root of 16 is 4. And isn't that the slope that we had there? We had the slope here, which was 3 over 4. That's that bottom value there. So just trying to connect you to the truth. Okay, so that's that, and of course there's also the negative version as well that we could have also played with, or we could have just taken that derivative. Actually, I think that's what we did here. We just took the derivative of that. So we used the power rule. Here's my chain rule, and then I rewrote this, and then I can see that I isolated. So hopefully you can see that. Okay, one last example. X squared plus y equals x, y squared equals y plus 7. There's a very common error here. So if we say what's the derivative of this, it would be 2x y prime plus 1 y squared, y to the power of 1 y prime equals y prime plus 0. This is totally incorrect, and I missed this. So which derivative laws will you need to use here? Okay, so what derivative laws do you need? Well, look at this. What's the operation between these two? Isn't it multiplication? So we're going to need the product rule and probably the power rule and probably the chain rule in this problem. Okay, so keep that in mind. So when we take the derivative of this, notice we're going to need to have the product rule there and the product rule there. I have helpfully color-coded this. There's f, there's g. F prime g plus f g prime. The derivative of y is y prime. Then we're going to do the same thing over here. Yes, this took a lot of time to color code this on Google Slides. So there's f, there's g, f prime g plus f g prime. It's a product rule. And now after this, it's just a matter of, again, what are we trying to find? We're trying to find y prime. So we need to get y prime on one side. So there's a y prime, y prime, y prime. I need to get all those terms to the same side. So I'm going to do that. I'm going to take them all to, I guess, this side. And then I'm going to factor out a y prime to get y prime on its own. And then there I go. Okay? You should know that if you take it to the other side, it would just look like this. This would be negative. This would be negative. This would be negative. This would be plus, and this would be plus. And those are equivalent. And I don't, this is probably a bit better because there's positives out there, but at the end of the day, I'm okay with either. And there you go. So I think that is all we need to say. I think we're going to call it there. And that's a pretty tricky problem, and I hope that helps.